Okay, so we are going to look at the problem that reads, at the 18th green of the U.S. Open, you need to make a 6.1 meter straight putt to win the tournament. When you hit the ball, giving it an initial velocity of 1.57 meters per second, it stops 1.8 meters short of the hole. Assuming the acceleration caused by the grass is constant between the putts, what should the initial speed have been to just make the putt? All right, so we are going to be asking the question, what should our initial velocity have been if we were going to make the putt, which means we're going to need to have some information about what actually happened. So let's go through our process. We first want to identify the object, and we're going to tackle this in the problem we want. What's the initial velocity that it should have been, so it can tell us what we need. We can go after what we need, so sort of that trusting in the process idea. All right, so what is our object? Well, we are interested in the golf ball. And again, remember, go through the process yourself, pause when you're stuck, watch the video, pause when I ask questions, kind of use this as a formative tool. All right, so what begins our motion? Well, when we hit the ball. And what ends our motion? When it goes in the hole, right? So we're looking at what would the initial velocity have to be to get the putt. So we're starting with that part of the problem. All right, so here's our golf ball, and here's the hole. So we have to identify the origin. We'll start, there, I have a little flag there. We'll start, have our origin identified where the golf ball is starting for the successful putt. And so X initial, our list of knowns, X final, V initial. V final, acceleration, and time are our variables. X initial, well, the ball is starting when we hit the ball at X equal to 0. In the case of being successful in the putt, we know that the ball goes, this is 6.1 meters away. Let me just double check that. Yep, you need to make a 6.1 meter shot, so we have 6.1 meters. We're trying to identify what is our initial velocity for the successful putt, so we don't know the initial velocity. The final velocity, well, it's just going to get there. It's just going to make that, so it's right when it comes to rest. We don't know our acceleration, and we don't know our time. All right, so we're interested in initial velocity. I have X final, I have X initial. I don't have acceleration, I have V final. So my equation that's likely going to be the most useful for me, because I do not have time, is the relationship between V final and the initial, acceleration and displacement. So V final is 0 equals V initial squared, we don't know, plus 2 acceleration we don't know, but delta X is 6.1 minus 0, and we get 0 equals V initial squared plus 2A times 6.1. We get negative 12.2 times acceleration is equal to V initial squared. And so my V initial, which is what I want, is going to be the square root of negative 12.2 times the acceleration. So I need the acceleration to solve this problem. Well, we are told that acceleration is constant between putts. So we could look at the case of the first scenario, the unsuccessful putt, to determine the acceleration. So the acceleration, which we need, is related to the unsuccessful putt. All right, so let's look at that scenario. My initial in the unsuccessful putt is when I hit the ball. My final in the unsuccessful putt is when the ball stops. So again, we have our ball. We're going to set the origin at the ball. And our flag's over here. Okay, So it stops 1.8 meters short of the hole. So if the hole is at 6.1, 1.8 meters short of that is 4.3. So it stops at x equals 4.3 at that location. All right, so let's set our list. X initial, X final, V initial, V final, acceleration and time. My X initial is 0. My X final is 4.3. V initial, well, we're told we hit it with a swing causing it to go 1.7 meters per second. V final is 0. I don't know my acceleration and I don't know my time. Now, we went after this because we're interested in acceleration. We recognize that that acceleration will be the same. And so, again, this equation is going to be our most useful, or quick efficient. So V final is 0. V initial is 1.57 squared plus 2 times the acceleration. And my delta x, V final, or x final minus x initial, is 4.3. So 2 times 4.3, so I have 0 is equal to 1.57. I'll do that one first. Where's my squared button? Right there, 2.465 plus 2 times 4.3 is 8.6a. Bring this to the other side, minus 2.465 equals 8.6 times the acceleration. Divide that by 8.6, and I get negative 0.29 equals my acceleration. So, those are consistent between putts. I can pull my acceleration over here, and I get the V initial is equal to the square root of negative 12.2 times negative 0.29. It's a good thing that was negative. Did I expect it to be negative? Well, my ball's moving to the right and it's slowing down, so the acceleration is opposite the direction of motion. Motion to the right, acceleration has to be to the left. So both checks on the negative. I needed negative in my square root, and of course, I needed negative based on the situation. So we multiply that by 12.2, take the square root, and we get an initial velocity of 1.87 meters per second. Now, the square root, remember, could be plus or minus, but we know the initial is positive 1.87 meters per second because of how we've defined that problem. All right, so is that expected? Well, 1.57 wasn't enough, so we expect it to be a higher value. It is a higher value. We identify it as positive. Our answer gives us a positive or a negative. We know it's positive because it's moving to the right. All right, so going after what we want that initial velocity to go to 6.1 meters. We don't know acceleration. Recognizing that that acceleration might be related to something else, it's related to the unsuccessful putt. So we analyze the unsuccessful putt, find the acceleration, and use it. All right, good job.